Assalamualaikum and salam sejahtera. Today's lecture will start with direction angle and direction cosine. But before I explain further on this first subtopic, I would like to recall on vectors. Okay, maybe I might drop or miss to explain on few things in a vector. So I will touch up in this slide. Okay, so first, what is a vector? Vector is a mathematical physical that has both magnitude and scalar. It is created by connecting two points. Okay, let's say if I have point P, A, B, C, and point Q, which is D, E, F. When I connect these two points from point P to point Q, I will create a vector that is called PQ. Okay, where PQ, vector PQ is equivalent to point Q minus point P. Okay, so DEF will minus with A, B, C. This will result a vector. D will minus with A, E will minus with B, F will minus with C. This will give you a vector, right? So for your information, this is one way of writing a vector. Okay, whereby looking at this, we know that this is for x component, this is for y component, and this is for z component for 3D plane. Alright. In some other book, there is one more way of writing a vector, where a vector is written in the form of I, J, K, where I represent the x-axis, J will represent the y-axis, and Z will represent K will represent the z-axis. Okay, so if you using I, J, K form, okay, you will write your vector in a addition or multiplication form. Okay, for example, this is Ri plus Sj plus Tk. Okay, where here R is equivalent to D minus A, S is equivalent to E minus B, and T is equivalent to F minus C. Okay, so this is the second way of writing the vector, the component for the vector. Okay, so you can write in between the arrow bracket, while you separate each component with a comma here, or you can write in the addition or subtraction of the component by writing it in I, J, K form. Okay, so to simplify this, okay, for example, PQ is equal to 2I plus 5J minus 3K. Okay, this can be simplified by writing in a component form 2, 5, separate with comma, and then minus 3. Okay, so this is by using the second method here. And this is by using the first method here of writing a vector. Okay. Another example is vector rs. You can write as minus I minus 2j plus 3k. This is equivalent to minus 1, separate by comma, minus 2, separate by comma, 3. So this is your x-axis, this is your y-axis, the second component, this is your third component, which is your z. Okay, so remember x, I, y is j, z is k. Alright, okay. Let's say if you have a vector on a 3D plane. So this is your x, this is your y, and this is your z. Okay, you have a vector that I name it as vector R. Okay, this is a vector on a 3D plane. Okay, for this vector, it starts from the origin O here to a point here that I name it as R. So when I connect the origin, the point at the origin to the point R, I'll create a vector OR, or I can just simply write R underscore. Okay. If I have a vector in 2D plane, this is your X, this is your Y. This vector is also vector R, OR. Okay. But this is just written into component X, component Y, while this one they have three components X, Y, Z. Okay, so a vector that is connected by 2 points, okay, where the starting point or the initial point is the origin, this vector is called position vector. This is also position vector because it starts from the origin to a point R. Okay, this is called position vector. Okay, if it is all positive, then it is I plus j plus k. Okay, if this is all the positive components, so this will be the I plus j only. Okay. Okay, each time a vector is created or plotted on 2D plane or 3D plane, it will create an angle. Okay, so regardless of the dimension of the plane, okay, whether it is 2D or 3D, when you create a vector, it will also create an angle. Okay, so there are three angles for 3D plane. Okay, so the angle that is from the x-axis. So let's say if you have point O here and point P here. So when you connect O to P here, okay, you will create vector OP. Alright, so this is called this is called position vector OP. Okay, from this vector, okay, it create an angle from three axes. Okay, so the first one is from the x-axis. Okay, so you can measure the angle from x-axis to your vector PQ here, OP here. Okay, and we denote this angle as alpha. Alright, if you measure the angle from the y-axis, okay, to your position vector OP here, okay, this angle we call it beta. Okay, beta. Okay, and the last angle is gamma. Gamma angle is the angle in between your z-axis to your vector OP. Okay, so denote as gamma. Okay, so alpha, beta, and gamma here are angle that we call direction angles. Okay, direction angles. Okay, where we measure the angle from the positive axis. Why it is positive axis? Because the angle is always in between 0 and 180 degree. So alpha, beta, gamma is always in between 0 and 180. Understand? Okay, clear on the direction angle, right? Okay, so next is, what is direction cosine? Direction cosine is the angle that we calculate based on the cosine term. So we know that for angle, there are three common trigonometry that we can use, right? We have cos, sine, and tangent. Okay, here we will only use cosine term to calculate for the direction angles here. Direction angle gamma, beta, and alpha. Okay, so all these three direction angles, we calculate the value by using only cosine term. Okay, so when cosine term, we need the adjacent and the hypotenuse. Okay, so cos is the adjacent to the hypotenuse. Any cos of any angle, okay, here which is alpha, beta, and gamma is always the adjacent over the hypotenuse. Okay, for all these three angles, the hypotenuse is always the length of your vector. The length of your vector here. So vector OP here, the length is the magnitude. Okay, so this is the hypotenuse. Okay, and the adjacent is always the respective value of the axis itself. If you find the alpha, okay, which is the angle from the x-axis, so you take the value of your x-axis over the hypotenuse. Because if we redraw this part, okay, we redraw this, okay, I redraw that. So that is vector OP. Okay, so this is vector OP. And this is always your x. Okay, so alpha is here in between the vector and the axis. Okay, so cos of this angle, okay, is the adjacent. What is the adjacent of the alpha? It is the value of x. What is the hypotenuse of this angle, the alpha? It is the length or the magnitude of vector OP. That's why you have this formula, and it applies to all the other two angles, beta and gamma. Okay, so beta, remember, it is the angle in between the y-axis and the vector, position vector. So take the y value over the length. So gamma is in between the angle in between the z and the vector. So take the z value over the hypotenuse. Okay, and make sure the angle is in between 0 and 180. Okay. Okay, let's go to the example. Find the direction cosine and direction angle. So direction cosine means you need to apply the cos alpha equal to x over the vector. Okay. If you want to find the cos beta, you need to take y over the that. And if you want to find the cos gamma, it is z over the vector. Okay, so it means here you need to leave your answer because it is direction cosine, right? So direction cosine means you leave your answer in cosine term. Okay, and direction angle is specific to alpha, beta, gamma. So you solve from the direction cosine, solve for alpha, beta, and gamma. That's why it is really important for you to understand the difference between direction cosine and direction angle. Okay, right. So the first one, you have a vector. Okay, you already have the vector because this is the way you write the component for a vector. So what you do is you just directly apply. Okay, so for cos alpha, okay, it is x over the vector. So just let us assume that this is a vector u, right? So vector u. Okay, we need the length of vector u here. Alright, so calculate the length. Okay, the magnitude for vector u. Given this in vector, so the length of vector u is equivalent to x square, which is 2 square, plus with negative 1 square, plus with 3 square. That is equivalent to 4, 1, 9. That is square root of 14. Okay, so the length or the magnitude of vector u is square root of 14. Now you can apply, you can substitute the value into the formula. So what is your x? X is the value of your x component. This is your x component. This is your y component. That is your z component. So x component is 2 over square root of 14. Alright, and to find the direction angle, which is the alpha, this is equivalent to cosine, okay, cos of 2 over square root of 14. Okay, so insert this into your calculator, you will get the value, the angle for your alpha is 57.69 degree. Okay, then solve for beta. Beta cos beta. Okay, we find the direction cosine first. Beta is the angle in between your y and the vector. So y, the value of y is here, negative 1. And the magnitude is here, which is square root of 14. Okay, now this is direction cosine. Okay, now find for beta your direction angle. Direction angle beta is equivalent to cos, you bring it to the right side, it becomes a cos of 1, negative 1 over the square root of 14. Okay. When you solve this, okay, insert into your calculator, you will get 105.5 degree. Okay, and do that for the third angle, which is gamma. Okay, so one more thing that I would like to remind you is be careful when you substitute the value into the calculator. Make sure you use the proper bracket. Okay, -1, you divide first with the square root of 14, and then you find the inverse of the cosine. Okay, so make sure you use the bracket. Okay, or else the calculator will give you the wrong answer. Okay, right. For the second example, okay, you were given 2 points. Okay, look at carefully. This is just a point P and point Q. So you know, right, what you need to do. Okay, let us consider that you need to find for vector PQ. Okay, wait a minute, I clean this first. Okay, what you need to do is you need to find vector PQ. So find vector PQ. It is point Q minus point P. Okay, this is equivalent to 1 minus 1 minus 0, 2 minus 1 minus 3 minus 1. Okay, so vector PQ is minus 1, 1 minus 4. Okay, so find the magnitude of PQ. We have minus 1 squared plus 1 squared plus minus 4 squared. That is 1 plus 1 plus 16. So you have square root of 18, which is equivalent to square root of 9 times square root of 2. Okay, that is equivalent. Square root of 9 is 3 over 2. Okay. Alright, and our respective component. This is your x component, this is your y component, this is your z component. So to find for cos alpha, it is the component of x over the length. Okay, so component of x is minus 1. So you have minus 1 here over with the length, the vector magnitude of PQ, which is 3 over 2. And then solve for alpha, which is the direction angle. This is the arc cosine of this term. Okay, so alpha is cos -1 of -1 over the 3, 2. Okay, and then you will get this answer. So you apply that to beta and to gamma as well. Okay. In our last meeting, I did mention that we have two ways of performing multiplication of vectors. Multiplication of vectors. First, by performing dot product. So we use symbol dot. Second is by performing cross product. And we use symbol multiplication, the cross. Okay. These two multiplications will give you different answer. Okay, if you perform dot product, it will give you answer in scalar, meaning it will give you magnitude only, number only. While if you perform by using cross product, you will get the answer in vector form. Okay, so here we can conclude that dot product will give you a scalar. Okay, cross product will give you a vector. Okay, later I will show you why we get a scalar for dot product. Okay, during solving the question in the previous meeting, I have shown you on how to do or to perform multiplication by using dot product, wasn't it? Okay, so if you perform dot product for vector u and vector v here, it means that you multiply the first component ui here with the first component of your second vector vi here. Okay, so ui, vi, multiply them, and then u plus with the multiplication of the second component, which is u2 multiply with v2, and then plus, okay, with multiplication of u3 with v3. You see? So multiplication will apply to the component respectively. Okay, first component with the first component, second component with the second component, third with third component. Okay, and you will sum them by using addition. Okay, you will get subtraction if your component is negative. Alright. Okay. So let us look at why do we get a scalar for dot product. Why didn't we get a vector? While we are actually multiplying two vectors. Why is the product is not a vector? Okay, that is a question. Why? Okay, to answer why, okay, let us write the vector in IJK form. Okay, so let's say I have vector u, which is I plus 2j minus 3k. And I have vector v, which is minus 1 or minus I minus 3j plus 4k. Okay, so I will perform dot product for vector u and vector v. I plus 2j minus 3k dot minus I minus j plus k. Okay, student, don't confuse because I use a common bracket here. Okay, I use common bracket here because we already write the vector in IJK form. So we know this is IJK form. So you don't need to put arrow bracket to this. Okay, so I put common bracket here, a normal bracket here, just to separate these two vectors. It's just for the purpose of performing the multiplication. Okay, okay, right. So when we multiply each component respectively. So I will multiply with I. Okay, where our first component here is I. Okay, so here I multiply with negative I will multiply with negative I. You got negative I dot I. Okay, so don't forget you need to plus 2j multiply with negative j. 2j multiply with negative j. Okay, plus with the third component, which is negative 3k, multiply with 4k, because 4 is positive. Okay, so the answer for this is negative I dot I. Okay, I dot I, according to the properties of the vector, it will give you the answer 1. Okay, so I dot I equivalent to 1. Same goes to J dot J. It will give you answer equal to 1. K dot K also give you 1. You see? So I squared equal to 1. J squared equal to 1. K squared equal to 1. Okay, for I squared here, don't get confused with complex number, okay? In complex number, I squared equivalent to negative 1. Okay, this is complex number. But for vector, I squared equivalent to 1. Okay? Okay, so here it is minus 1. Plus with, this is negative 6j squared. So you get only negative 6. This is negative 12. Because k dot k is equal to 1. So you will just leave it answer 12. Right? So that's why the answer is in magnitude or just a scalar. Minus 1 minus 6 minus 12, that is minus 19. Okay? If you don't want, this is the explanation why when we do a dot product, we will just get a scalar. Okay? Because of this. That's why when we perform dot product, we don't even write the I, J, K term. We just concentrate to the value of the axis, which is 1, 2, minus 3 for vector U. And for vector V, it is minus 1, minus 3 for this is vector V. And we can multiply this directly and you will get similar answer, which is negative 19. Okay, so let us look at the example here. Number 1, we need to perform for u dot v. So u dot v is equivalent to 2 minus 3, 1 dot 0 minus 2, 3. So 2 will multiply with 0, that will give you 0, plus with minus 3 times minus 2, that will give you 6, plus with 1, multiply with 3, that is 3, so the answer is 9. So for number 2, is minus 2 times with vector u dot v, vector v. Okay, so you can solve for minus 2 times with vector v first, or you can multiply scalar minus 2 later at the end. So you can solve for this first, and then you dot product with v, or you can perform u dot v first, okay, and then the answer you multiply with negative 2. Okay, since we have calculated the multiplication dot vector dot product for uv, which is 9, so we just insert 9 here. So minus 2 times 9, that is minus 18. Okay. One of the application of dot product is to find the angle between two vectors. Let's say if you have vector v and vector u here, and they are connected to each other by their initial point. Okay, so in this position, they will create an angle, okay, that we denote as theta. So this theta, we can find it by applying this formula. Okay, so find the theta by finding the dot product of vector u and vector v. Okay, u and v here. Perform the dot product. Okay, over the multiplication of the length u and length v. Okay, find the magnitude of u, find the magnitude of v, multiply them. Okay, and then you get the theta by a cosine of u dot v over the magnitude of u, magnitude of v. Okay, so that don't confuse this cos with the cos that we learned in the previous slide. Okay, that cos is cosine angle. Okay, or we call it direction angle. That is different. Okay, where we find the cos alpha, cos beta, and cos of gamma. Okay, also by using the cos term, this is x over the magnitude of vector OP. Okay, this is y over the magnitude of OP. This is z over the magnitude of AOP. They still use the same concept, okay, where you find the, you take the value of your z, your x, and your y, and then over the magnitude. Okay, same concept that you apply here. You get a scalar from the dot product of u and v, and you divide them by the multiplication of the magnitude between u and vector v. Okay, same concept used, but this one is called direction cosine, which is the angle that you find from a vector. Okay, you just have one vector and you calculate the angle, which is alpha, from the x-axis. So it is between the vector and the axis. While this one, this cosine theta, is the angle in between two vectors. First vector, second vector. This one, a vector and the axis. Understand? Okay. So if you find out that your theta here is equivalent to 0, that simply means that vector u and vector v are parallel. Okay, so there are two possible parallel position that they have. The first one, when they have a same direction, okay, like this, okay, or they are in inline position. Okay, beside the parallel vector, applying dot product can tell whether the two vectors are perpendicular or not. Okay, perpendicular, also known as orthogonal. Okay, so these two words are similar. They have same meaning. Okay, you can call it perpendicular or you can call it orthogonal. Okay, so make sure that you keep these two words in your mind. Okay, perpendicular and orthogonal means the two vectors create 90 degree. Okay, so the angle between vector u and vector v is 90 degree. Okay, 90 degree or pi over 2. So let's say this is u, this is vector v. Okay, when will this situation occur? This situation will occur when you apply the formula cos theta u dot v over the magnitude of u times the magnitude of v, and you find for theta, you got theta is pi over 2 or 90 degree. This means that your two vector, vector u and vector v, create 90 degree. So u, v. Okay, so this situation, okay, will occur whenever the numerator, okay, which is u dot v is equal to 0. Alright, when this dot product equal to 0, you will get cos theta equal to 0, and theta will be pi over 2 or 90 degree. You can calculate this from your calculator. Okay, your denominator, which is the magnitude of u times the magnitude of v, cannot be 0. If the denominator becomes 0, your cos theta will be undefined. Okay, if you calculate the value, you will get math error. Okay, so thus to get theta equal to 90 degree or pi over 2, your numerator must be equal to 0. Alright. Okay, so to summarize this, okay, by applying dot product, okay, when your theta is equal to 0 degree, means vector u and vector v are parallel. Okay, so they can be parallel in many ways. Okay, or they are in line. So there are only two possibilities, whether they are parallel in any direction. This is also parallel as long as they go to the same direction, or they can be parallel like this, they can be parallel like that, or they can be in line. Okay, so the two vectors are in line. Okay, when you apply dot product and you got theta is equal 90 degree, this means your vector u and vector v are perpendicular or orthogonal. Okay, when the vector create 90 degree, they are called perpendicular or orthogonal. Okay, when will you get 90 degree? Whenever your dot product u dot v is equal to 0. Okay, because from the formula of cos theta equal to u dot v over magnitude u times the magnitude of v, your numerator here cannot be equal to 0. Okay, because when this equal to 0, denominator equal to 0, you will get undefined. Thus, to get theta equal to 0, this should be 0. Okay, so dot product should be 0. Automatically, you will get theta equal to 90 degree, and thus you can conclude that your two vectors are perpendicular.